and graph. So for the domain, I don't think you have any issue. You just look for the part where you see a square root, okay? And make sure this part is defined. Anything else has no issues. For example, you have x plus 2. This x plus 2 that is inside or under the square root must not be negative. That means must be more or equal than 0. That's all. Okay. And then you have to find the values of x. Just subtract 2 from each side, and you get your x. Okay. Can you write it down? X more or equal than negative 2. That's your domain. That's your domain. This question you have to be careful at because you have to solve the inequality, whatever inequality you have, okay? Now we go to the range. To find the range, you have to look for the values of y. The range are what? The values of y, or the values that y can take. These are the values of y, we call them the range. Okay, so we look at our function. This expression is the y coordinate, okay? So what are the values of y? It's very simple. Start from the square root. Square root is always not negative. That means you put square root of x plus 2 more or equal than 0. Can you write for us? Square root of x plus 2 here more or equal than 0. Good. You start from here and always start from square root. Square root is always not negative. It's like absolute value, okay? Then when you multiply by 4, multiply each side by 4, you get 4 square root of x plus 2 more or equal than 4 times 0. 4 times 0 is 0. Okay. So, yes, 4 square root of x plus 2 is more or equal than 0. And then you come to this minus 3, subtract it from each side. Subtract 3 from each side. Minus 3, minus 3. Yes, and you get 4 square root of x plus 2 minus 3 more or equal than negative 3. This means that your y is more or equal than negative 3, and that's your range, okay? That is your range. Now we come to this. How does the graph of the function given, which is this function, compare to the graph of square root of x? This is the parent function. Sometimes they mention it with the expression. Sometimes they just say the parent function. If they say the parent function, they mean square root of x. So they're talking about transformations here. So you describe all the transformations, okay, that maps this square root of x to the expression given in the question. So you have this plus 2. This means 2 units to the right, to the left. When you have plus, you say left. This is actually a shift, horizontal translation. Make sure you mention it. Horizontal translation. Okay. 2 units to the left. That's the plus 2. This plus 2 here. Times 4. Times 4 means what? Stretch. Stretch of factor 4. Okay. Remember, if the factor is more than 1, we say stretch. If the factor is less than 1, between 0 and 1, we say compress or shrink. That's for the vertical. So this stretch is vertical. So make sure you mention it's vertical. Vertical stretch, because it's in the direction of y. If it was inside, like 4x inside, then it's horizontal. And the factor is the reciprocal. If they put 4, you say factor 1 over 4, and it becomes a compress, okay? Now, the other transformation here is -3. This -3 is in the y direction. So it's a vertical translation, 3 units. And because you have minus, you have to say down. That's all. This is how you describe or how you compare between the two graphs. Sometimes they say compare, sometimes they say describe the transformations, and they're gone. So they are equivalent questions. They ask you in different forms, but they mean the same thing. Now we come to sketch the graph. To sketch the graph is either you start from this square root and you do this transformation and you get your graph, or you use few points by substitution. I think I advise you to use points. You know why? Just in case you get your transformations wrong, okay? So if we want to use points, we have to dress a table for the values of x and y. So can you, now here, there's a small table here for the graph, okay? Let me put the red color. This is your 3 points are enough, okay? In the exam, if you plot 3 points and join them, you are fine. However, you need to know how to choose your points. For example, the starting point. Starting point should be from the domain, -2. You cannot start before -2, so put -2 as the first value for x. So write down here x, and here y, okay? And start with -2. Okay, after that, we have to put another value. You have to go in the direction of the domain. The domain is going from -2 and above. So you increase, so you go to more than -2, which is -1, 0, 1. Wait, don't rush. I'm going to choose a value that helps me to calculate the square root to get like a whole number. Okay, not a radical. So -1 would be fine because -1 plus 2 is 1 and square root of 1 is 1. So put -1. And then we need another point. After -1, we can have 1. It's not helpful. 1 plus 2 is 3. Square root of 3 is not like integer. So we go to 2. 2 plus 2 is 4. So you jump to 2 now. Go to 2. Good. Now we have 3 points. They're going to help me to graph this function properly. Now we calculate, okay? So with -2 as a value for x, when I substitute here, I get 0. And this 0, square root of 0 is 0 times 4 is 0. So you get only -3. So put your -3. If you don't know how to calculate it mentally, use your calculator. Just use this function and substitute x with these values. -1 now. When x is -1, -1, get -1 plus 2 is 1, square root of 1 is 1, 1 times 4 is 4, 4 minus 3 is 1. So you get 1. Now with 2, you get 2 plus 2, 4, square root of 4 is 2, 2 times 4 is 8, 8 minus 3 is what? 5. Now we have our 3 points, we just plot them. So we put -2, -3 here. This is your point. No, we're going. That's 2. Bismillah. That's 2. Put -2 here. Now the point is here. Okay, this is your starting point because the function starts from -2. So you're going to start here. There is nothing before. And then you put -1 and 1, which is this point. Good. And then you put 2 and 5. What is 2 and 5? This is 2, 1, 2, 3, 4, 5, this point. Good. And now just join them with smooth curve, and remember square root, the parent is like this, okay? So you graph a function that goes like that. exactly the same shape, okay? I'm going to remove it and you draw it because maybe you draw it much better than me. Use the red color. Excellent. Now we can check, for example, our transformation. 2 units to the left, the square root of x starts here. If you move it to the left, it goes here. And 3 units down, which is this point. Can you see 2 units to the left and 3 units down? That if, for example, the start point is going to go 2 left and 3 down, which is this point. Okay, the stretch, can you see the stretch? It's 4. Okay, can you see the stretch? Normally, your function should be here, like this, from 1, 1. So if we count 1, 2, 3, 4, can you see the 4? That's your stretch. Okay, that's it. You don't need to check this stretch anyway. You only need to graph it. And I hope it's going to help all of you. In the next page, I have another function that is a little bit confusing some students, okay? Find the domain and the range, then graph the function and describe transformations applied on the parent function. Can you see here they don't mention the function, the parent function. So what you start doing, domain, you put x plus 1, which is under the square root, put it more or equal than 0. For the domain, always look for the values that makes the expression defined. That means the square root can be calculated. The square root can be calculated is the expression inside the square root is not negative. This gives me x more or equal than -1. Excellent, that's your domain. Now the range. We know that square root must be more or equal than 0. So we start there. Square root of x plus 1 more or equal than 0. Write it down there. This is not the range, huh? Yes, square root x more equal than 0. Then we have to multiply by -2. So if you multiply by -2, what do you get? You get -2 square root of x plus 1 less or equal than 0, because you multiply by negative. If you multiply a positive by negative, you change direction. Less or equal than 0. Not more. Here. Less or equal. Yes, because it's -2 multiplied by positive. So if you multiply -2 by positive, you get a negative. Okay. Now this is our range. So the range is y less or equal than 0. Write it in red. Y less or equal than 0, because this is my y. Come on. Now describe the transformation. Transformation here, we have 3 transformations. We have the horizontal translation to the left, 1 unit. So write down here, horizontal translation, 1 unit to the left because of this plus 1. Always when you have plus, you say left. When you have minus, you say right. Good. And we have this 2, which is a stretch, a vertical stretch of factor 2. These 2. And this minus, I hope you remember it. This minus is a reflection. Okay. So I said vertical stretch factor 2 and a reflection across the x-axis. Excellent. These are transformations applied on the parent function, which is square root of x. After we do this, we go and graph. It's up to you. You can use the transformation if you are smart at moving, or just use a table. Let's use a table. Okay. I advise all of you to use a table, because in a table you are secure and safe. Okay, so you put the values of x and y. Where do we start x from? From the domain. The first value is -1. Okay. And then we go to the next value, which is 0, because 0 plus 1 is 1, and square root of 1 is 1. So we can calculate with 0. And then we cannot use 1, because 1 plus 1 is 2. Square root of 2 cannot be simplified like integers. So we go to 3. 3 plus 1 is 4. Make sure you get 4 inside, okay? Now let's calculate. -1 plus 1 is 0. Square root of 0 is 0 times whatever is 0. So we get 0 here for y. And here for 0, we get -2. Just calculate here. Square root of 1 is 1 times -2 is -2. And then for 3, you get 4. Square root of 4 is 2. 2 times 2 is 4. So you get -4. And you just plot these points. So you put -1 and 0. Let me zoom. Yes. And then 0 and -2, which is this point. And then 3 and -4. 3 is here. -4 is here. So this is your point. Now just join them with smooth curve, and you're done. That's it. If you want to see your transformation, square root of x is like this, okay? Can you see the reflection? It's reflected, okay? And then it's translated one to the left. And then it's stretched, okay? Because if you just reflect, you get this function. But with the stretch, you get like this too. And that's it. Here we are. Any question?